We looked in the previous video about finding points of intersection with parabolas and purely horizontal lines. Now in this video we're going to move on to some different types of lines, because we remember that our lines can have a variety of different slopes, and oftentimes we're not going to just be working with horizontal lines. We want to find solutions to simultaneous equations with all sorts of parabolas, all sorts of different lines. So we're just going to jump straight into some questions, because I gave a good background into this last time in the last video. So let's solve this pair of simultaneous equations. And in all of these examples, I'm going to be doing this using substitution. So we noticed before that since I'm finding points of intersection, so for example, I have a parabola and I have a line, in some cases there'll be zero solutions or 0 points of intersection. Sometimes you'll have one, sometimes you'll have two. But anytime we have these intersecting points here or here, we remember that the x coordinates at those exact points are identical, they're the same, and the y values are exactly the same. So we're going to use that idea to say that, well, since these y's are exactly the same, then these two are exactly the same as well. So we can use this substitution to get rid of the y variable. So we can say that x squared here is going to equal to 2x. The y's are the same, so these terms on the right hand side, these pink ones, are the same as well. Because they're the same, we can set them to be equal to one another. And now we can just shuffle this around a bit to make a quadratic equation in standard form. So we're going to subtract 2x from both sides. And remember, standard form just means everything on one side, the quadratic on one side equaling to 0 on the other side. So we get x squared minus 2x equals to 0. And now I can see this is actually a bit of an easier one to solve. I can just pull out an x as a common factor in both of these terms, and x goes into x squared x times when I factorize this, and it goes into negative 2x negative 2 times, and that equals to 0. Now remember, here our two terms here are multiplying, so we're going to use our null factor law, which tells us that in order to have 0 as a solution, well, in order to have this left hand side equaling to 0, since this is a product, one of these terms has to equal 0. Therefore, we can say, now I'm just going to go through this quickly because we should already be comfortable with this. One of those is x equals 0 and x minus 2 equals to 0. And solving the second equation for x, a value of x that makes x minus 2 equal to 0 is going to be 2. Because 2 minus 2 equals to 0. Now, those are my two solutions. And once I have these two solutions, well, I have two x coordinates where these two intersect, where my parabola intersects with my line. Therefore, I'm going to have two intersection points. And I can figure out what these are by substituting x equals 0 and x equals 2 into one of my equations. Now remember, since these points are, well, since these two lines are meeting at those exact points, I can either substitute this into equation 1 or equation 2. Now it's up to you which one you want to choose. They're about the same level of difficulty to substitute in. I'm just going to substitute this into 2. So I'm going to get y equals 2 times 0, subbing this point in first, which just gives me 0. And my other one, I'm subbing in 2 here, So y equals to 4. So I can say, therefore, my points of intersection are when x equals 0, y equals 0. So one of those points is 0, 0. And another one is going to be 2, when x equals 2, y equals to 4. So the other point is going to be 2, 4. Okay, let's try one more example. I'm going to jump to a slightly trickier one, but we're going to go through this really, really slowly and using our substitution method again. So my first equation is y equals to x squared plus 1. My second equation is 2x minus 3y equals to negative 4. And I want to somehow come up with a substitution here. Now, remembering we said before that at these points of intersection, our x's are going to be equal and our y's are going to be equal as well. Now, I'm going to, because there's an x squared here, that's going to be a little annoying to make x the subject. So I'm going to make this y down the bottom the subject of my equation, so have it on its own, so that we can do the substitution trick we did before. So looking at equation 2, I have 2x minus 3y equals negative 4, and I want to shuffle this equation around a little bit to get y on its own. So I'm going to add 3y to both sides, and I'm also going to add 4 to both sides to get the y on its own on the right and everything else together on the left. So I'm going to get, let's use the same color, 2x plus 4 equals to 3y. So now getting the y on its own here, I'm going to divide both sides by 3, and I get that 2 over 3x plus 4 over 3 equals 2y. Okay, now this is a little annoying, but we can still work through this using substitution. So I'm going to set, since I have a y here on its own and I have this y on the left hand side, both of those are equal at the point of intersection. So I can set the x things on the other side to equal each other. So I have here, using substitution, I have that x squared plus 1 equals to 2 over 3x, or 2x over 3, doesn't matter, plus 4 over 3. And actually I can just write these on the right hand side as the same fraction. Plus 4 over 3. Okay, so now I want to start cleaning this all up, get this as a quadratic equation in general form. So everything on one side equaling to 0 on the other. Now first thing I want to do is I want to get rid of this dividing by 3 here. I want to kill off my fraction, and I'm going to times both sides by 3. So I'm going to get 3 outside of x squared plus 1 equals to 2x plus 4. And now here, remember, this 3 is multiplying by this whole bracket, both of these bracket terms. So when we expand brackets, we want our outside term to get multiplied by the 2 inside terms. I get left with 3x squared plus 3 equals to 2x plus 4. And I want to get these guys on the right hand side over to the left hand side. So I'm going to do this opposite operation, cancels out both of these on the right hand side, leaving me with 0. And on the left hand side, I wind up with 3x squared minus 2x, and I have positive 3 minus 4. That gives me minus 1. And that equals to 0. Okay. Now, for this thing here, there are a couple of ways you can do it. You can do it with PSF. I'm just going to use the quadratic formula just for the fun of it, because we've talked about it a lot, so we're going to practice using this, and we're also going to be using this a lot more in the next video. So this is kind of like a warm-up to that. Now, remember these coefficients are my terms A, B, and C, and I'm going to use my quadratic formula, which tells me the solution of x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. And I just want to substitute a in the place of a, this negative 2 in place of b, and negative 1 in place of c. So I'm going to get x equals to minus 2, so minus 2 plus or minus the square root of minus 2 all squared minus 4 times 3 times minus 1 all over 2 times 3. And you guys can do this one slowly yourselves and work through this, but I'm just going to go straight to the answer because I'm more concerned about the solving simultaneous equations here. So I get solutions of x equals to minus 1/3 and x equals to 1. Now, feel free to pause the video, have a go at computing this, or just pop it into your calculator. That's what it's there for. And now we have the two x coordinates. So what we want to do is we want to sub x equals negative 1 over 3 and x equals to 1 into one of our equations. So we usually go for the path of least resistance here. I'm actually going to go to equation 1 because there's a lot less fiddling around and moving the equation around. So I'm going to sub these into equation 1. And that's going to give me my y coordinate of this point of intersection. So I have y equals to minus 1/3 squared plus 1. And that's going to give us 1 over 9 plus 1, which equals to 10 over 9. And I'm also going to sub x equals to 1 into this equation. So I get y equals to 1 squared plus 1. And that just equals to 2. Therefore, my points of intersection are just these coordinates here. When x is negative 1/3, y is 10/9. That's going to be negative 1/3, 10/9. And when x equals 1, y equals 2. So that is my next point. 1, 2. So that brings us to the end of this video. This was all about using substitution to solve non-linear equations. So we're doing the same thing as substituting when we did linear simultaneous equations. It is the same process. We're just making y, for example here, the subject of both equations. We made the y subject here, and for equation 1 we had y as the subject. So doing that allows us to set the x variables, the right hand sides of these equations, to equal each other and solve for x. Now here we usually get more than one solution, not always. We'll encounter a bunch of examples where we don't, but that is going to bring us to the end of this video in particular, and I will see you guys in the next one.